Dear students, today we shall discuss about application of matrices and determinants. We already studied about determinants and matrices. Now, today we study about application of determinants and matrices. For solving system of linear equations having two variables or three variables for checking consistency of the matrices or linear equations. What is consistency and inconsistency? First, we discuss the consistency and inconsistency. Application of matrices and determinants. First one, consistency. Consistent system. Here we solve the linear equations by using matrices and determinants. Here some linear equations, some system, if it has two variables, we have to give two equations. If three variables, we have three equations, three linear equations. In this system, three or two equations are there, no? That was the system of equations. A system of equations, is said to be consistent if its solution exists. If linear equations are there, a system of equations is said to be consistent if its solution exists. If inconsistent system, here a system of equations is said to be inconsistent if its solution does not exist. If there is a solution, we can find the solution. If there is no solution, we can't solve the equation. Therefore, we have to first check the equations consistent or inconsistent. Consistent system. A system of equations or linear equations is said to be consistent if its solution exists. In a consistent system, a system of equations is said to be inconsistent if its solution does not exist. Next, we solve the linear equations by using matrices and determinants. Here, we already studied about finding the A inverse of the matrix. Then finding the determinant value of the matrix also. By using these two, we find the solve the system of linear equations. Let us consider three linear equations. A1x plus b1y plus c1z is equal to d1. Then another equation a2x plus b2y plus c2z is equal to d2. Then a3x plus b3y plus c3z is equal to d3. There are three linear equations because there are three variables x, y, z. Therefore, we have to take three equations. Then we express these linear equations, in equation matrix equations. A is equal to matrix A1, the coefficients of the x, y, z of the first equation, therefore A1, B1, C1. Then second equation, coefficients are A2, B2, C2, A3, B3, C2. A1, B1, C1 are the coefficients of first linear equations x, y, z respectively. Then the same I continue in the second equation and third equations also. One by one, row, three rows, I write the coefficients of the linear equations on left hand side. Then x is the variables. Which are the variables? X, y, z is the second equation. Then B is the another equation, the matrix. This is which one is D1, D2, D3. We write the three matrices by expressing the coefficients of the linear equations and in the RHS side also. We get three matrices. We write it in the equation form. I write it as in the equation form. Ax is equal to b. Ax equal to b. Here, A is A1, B1, C1, A2, B2, C2, and A3, B3, C3. Then x is equal to x, y, z is equal to D1, D2, and D3. Is the equation. Then we have to find the value of x, y, z. Therefore, I find the x value. Case 1. Ax is equal to b. I multiply A inverse x by pre-multiplying. A inverse x, A inverse both sides. A inverse of A into x is equal to A inverse b. A inverse into A is equal to I. X is equal to A inverse b. Therefore, I into x. I is the identity matrix. A inverse into A is equal to I. Then x is equal to A inverse b. We have to find. It means x is equal to x, y, z is equal to inverse of the matrix A and the matrix B. We multiply the matrices A inverse and B, we get the x value, means x, y, z variables. We have equating the terms, the corresponding terms, we get x, y, z value. In the same way, here we have to find x is equal to A inverse x is the first case. But here matrix provides in the matrix method, it provides unique solution for the system of linear equations. Here x, y, z have unique solution because A inverse is unique. For every matrix A inverse is unique. Therefore, this also having only one solution. Then in the second case, here determinant finding the A inverse, determinant value should be existence. It's not equal to 0. I will tell later that also. In case 2, it is case 1, Ax equal to B. In case this method is also called as matrix method. Solving the equations, this method is called matrix method. Case 2, if A is a singular matrix, if here A is a non-singular matrix, A is a non-singular matrix, then only we find this. It's having unique solution. But case 2, if A is a singular matrix, it means determinant value is equal to 0. We can calculate if determinant value is 0, we calculate adjoint of A into B. Adjoint of A into B. If it is not equal to 0, if adjoint of A into B is not equal to 0, then the solution does not exist. Then the system of equations is inconsistent. The system of linear equations is inconsistent. If it is equal to 0, if inconsistent, it's not inconsistent, no solution. If adjoint of A into B, it is equal to 0, we can't say it is consistent or inconsistent. It is inconsistent or consistent. It's having solution in finite solution or not. We solve the consistent equations only, system of equations only in one syllabus. Then we go to solve some problems here. It's the steps. First, write the A, X, B matrices using the linear equations. Then find the determinant value. It gives us the matrix is consistent determinant value. Finding the determinant value. It's singular or non-singular. If it is singular, we don't go to find the A inverse. because A inverse does not exist. Therefore, we find the determinant value of A first. Judge the we go to the find the or to solve the system of the equations or not. I take one problem here. Examine the consistency of system of equations and solve the system of equations. Solve the equations. First one, x plus 2y is equal to 2. Another equation is 2x plus 3y is equal to 3. In this system of equations, two variables are there, x and y. Therefore, to solve these two equations are sufficient. We write the first matrix A, taking the coefficients of x and y. 1, x the coefficient is 1, y the coefficient is 2. Then this one is 2, this 3. Then x equal to x and y. B is equal to 3. The three equations. First we find the determinant value of A. Determinant value of A is equal to 1 into 3 is 3 minus 2 into 2 is equal to 4 is equal to minus 1. It's not equal to 0. Therefore, its matrix is singular. Or singular. A is singular matrix. Non-singular matrix. Non-singular matrix. Then we find A. First, it's consistent. Determinant value is not equal to 0. Therefore, it is consistent. Therefore, we find the solution of these equations. We have unique solution. Ax equal to B. There x equal to A inverse into B. X is equal to adjoint of A by determinant of A into B. We are finding the adjoint of A is equal to, it's a 2 by 2 matrix. We can find the adjoint easily by interchanging the principal diagonal elements. 1 and 3. We get 3, 1 and change the sign of other two elements minus 2 and minus 2. It's adjoint of A. Then B. Therefore, x is equal to 1 by minus 1. 1 by minus 1 is the determinant value. I put the values in this equation. Adjoint of A is 3 minus 2 1 into B. B is the matrix 2 3 is the single row. X is equal to minus 1 into 3 into 2 6 minus 2 into 3 plus 6 minus 6 minus 3 into 2 plus 6 minus 2 into 3 minus 6 minus 2 into 2 minus 4 and 1 into 3 plus 3. Then x is equal to minus 1 into 0 minus 1. We get multiply the two elements by minus 1. We get 0 and 1. But here X means they having X matrices having two elements. The first column, only one column, X, Y, equating the corresponding elements. It's an equal matrix. Yeah, equal matrix. They are equating the corresponding elements. X equal to 0, Y is equal to 1. These are the solutions of this equation. You can carry the equation also here. You put the values in X equal to 0 plus Y is equal to 2 into 1, 2 is equal to 2. We equate this equation also. Therefore, the solutions are correct. Yeah. Once again, you follow the steps here. To given two equations, here two variables. Write the three matrices of coefficients of the x and y. First and second equation, first row and second row. Then x is the having two elements, x and y. Then b is the matrix of having d1 and d2. Then finding the value of determinant of A is equal to 0 or not equal to 0. If it is non-singular, then here it must exist. It having unique solution. Then we find the solutions. By x is equal to b, x is equal to A inverse b. A is we already studied in the previous class. X adjacent of A divided by determinant of A. Then we multiply this one into B, we get X. Adjacent of A of 2 by 2 matrix by interchanging principal diagonal elements and changing the sign of the other two elements and putting the all values in this equation and solving by find the product of these two, result of A and B, then multiply by 1 by determinant of A, we get the equation, and solving the two, we get two matrices. First one is unknown x and y. Second matrix is 0 and 1, equating the corresponding elements. In the matrices class, we studied equal matrices. Here, equating the corresponding terms, we get solution of x and y. Now, we take 3 by 3 matrix or inconsistent. Check the another problem. Second one, x plus 3y is equal to 5, 2x plus 6y is equal to 8. Examine the consistency of system of equations. First, we write a is equal to 1, 3, 2, 6. Then x equal to xy. And b is equal to 5, 8. Three equations. First, we find the determinant value of A. We get 6 minus 6, which is equal to 0. But here, determinant value is 0. Then, we find the adjacent of A into B. Determinant value is 0. We move to find the adjacent of A into B. Adjacent of A is equal to interchanging the rows, principal diagonals 6, 1 and minus 2, minus 3. B is the matrix 5 and 8. We get here 6 into 5, 30. minus 24 minus 2 into 5 minus 10 plus 8. We get 30 minus 24 is equal to 6 minus 10 plus 8 is equal to minus 2. But it is not equal to 0. 0 means 0 matrix. 0 by 0 matrix. It's not equal to 0. Therefore, we say it's an inconsistent. It's an inconsistent. If it is 0, we can't say it's consistent or inconsistent. But it's not equal to 0. Therefore, the system of equations are inconsistent. Is inconsistent and no solution. No solution. Right? If determinant value is equal to 0, then we find the value of adjunct of A into B. If it is not equal to 0, the system of equations is inconsistent and have no solution. Next, we go to system of equations of having three variables. It's having three variables, we should take three equations. Three equations. Solve the system of equations by solve the system of equations, linear equations by matrix method. Here, using matrix and determinants, therefore, we will call it as matrix method. First equation is x minus y plus 2z is equal to 7. Second is 3x plus 4y minus 5z is equal to minus 5. Then 2x minus y plus 3z is equal to 12. Here x minus y plus 2z is equal to 7. 3x plus 4y minus 5z is equal to minus 5. 2x minus y minus 3z is equal to 12. Now we write the three matrices from taking corresponding elements or coefficients of the x, y, z. First, second, and third. First equation, second equation, and third equation. 1 minus 1, 2. 3, 4 minus 5, 2 minus 1, 3. Then x is equal to x, y, z. There are three variables, therefore x is equal to x, y, z. Then b is equal to the RHS side. Which one elements are there? That is the b matrix. Minus 5, 12. 7 minus 5, 12. Here, x is equal to b. X equal to b. X is equal to A inverse of b. Here, finding the A inverse, we have to find adjoint of A and determinant of A. Therefore, we have to find adjoint of A. Adjoint of A is found by cofactors of the every elements of A. A. Which one? Finding the cofactors of matrix A or cofactors of A. Therefore, we find A11, A11, A12, A13, then A21, A22, A23, then A31, A32, and A33. There 9 elements we have to find the cofactors. First one is plus, here is minus, this one is minus, plus. Here minus, plus, minus. Here plus, minus, plus. Further, A11, A. First we find the determinant value. A is equal to 1 into. First we find the determinant value of A. The A inverse exists or not. A11 is equal to 12 minus 5 into 1 plus 5. 12 minus 5. 1 into 12 minus 5 minus of minus plus 1 into 9 minus 10 plus 10 minus plus 2 into minus 3 minus 8 you get 12 minus 5 it's 7 plus 19 minus 11 into minus 22 which is equal to 19 plus 7 is 26. 26 minus 22 is plus 4. It's not equal to 0. Therefore, A inverse exists. A inverse exists. A inverse. Then we find the A is equal to B, A inverse B. Then find the cofactors of A. Plus, first one is plus. First, A11 is this one. Then find deleting this terms and finding this. We can take this method. 4 into 3, 12. 4 into 3, 12. ಸ್ವಲ್ಪ ರಿಸರ್ಚ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. A11 is 12 minus 5 which is equal to 7 and 1 2 is equal to minus 19. Yeah. Deleting these two terms. 9 plus 10 is plus 19. It's minus 19. A13 is deleting these two. 3 minus 3 minus 8. Minus 3 minus 8 is equal to minus 11. Minus 11. Then A21 is the 11 minus 3. This one is 3. Deleting these two columns. First column and second row. We get minus 1 into 3 minus 3 plus 2. Minus 3 plus 2. We get minus 3 plus 2. Get 1, it's minus 1, it's plus 1. Then A22 is this one. 1 into 3. 3 minus 4. 3 minus 4. We get minus 1. Yeah, minus 1. And a to 3. A to 3 is this one. We get minus 1 plus 2. Minus 1 plus 2. It's a 2 minus 1 is a plus 1. It's a minus 1. Then 3 1. 3 1 is 2. We get the minus 1 and 2 and 4 5. Minus 1 into minus 5. It's a plus 5. Minus 8 minus 8, we get minus 8 minus 3 is minus 3. Then 832 is 832 is 1 into minus 5 minus 6, we get minus 11, so plus 11. Then last one is the 3 is this one, 4 plus 3, 4 plus 3, which is equal to plus 7. We get 7, 1 minus 3 and minus 19 minus 1 plus 11. Then minus 11 minus 1 plus 7. These are the cofactors of the elements of A. Elements of A. I take in transpose also. A11, A12, A13 here. Therefore, transpose of this, we get adjoint of A is equal to 7 1 minus 3 minus 19 minus 1 plus 11 minus 11 minus 1 and plus 7. It's the adjoint of A. It's the adjoint of A. Then we have to find the A inverse or X. This we substituting this, we get X is equal to adjoint of A divided by determinant of A. X is into B. X is equal. Here A is equal to B. X is equal. A inverse is equal to this one. Therefore, putting this value in this one, X is equal to 1 by adjoint of A in a determinant of A is 4. Then adjoint of A is equal to 7, 1 minus 3 minus 19 minus 1 plus 11 minus 11 minus 1 plus 7. Then here X is X, Y, Z. We get it 1 by 4 into B matrix is 7 minus 5, 12. We get multiplying this one, 7 into 7, 49, minus 1 into 5, minus 5, minus 3 into 12, minus 36. Then 19 into 7 is minus 133 plus 5 into 1 minus that is plus 1. Then 11 into 12 is equal to plus 132. Then minus 11 into 7 minus 77 minus into minus plus 5. Then 7 into 12 plus 84. We get 1 by 4 into 49 minus 5 minus 36 is equal to 8. Then minus 133 plus 5 plus 133 is equal to 137 minus 133. This one we get 4. Here minus 1 is there. 5 minus 1 is 4. Then 7 is minus 77 plus 5, 84. We get again 12. 84 plus 5 is 89 minus 77 is equal to 12. We get it divided by 4. 8 by 4, 2. 4 by 4, 1. 12 by 4 is 3. Therefore, x, y, z is equal to 2, 1, 3. Therefore, x is equal to 2, y is equal to 1, and z is equal to 1. These are the solutions of the linear equations in this system. First, we write the coefficients of the x, y, z of the linear equations respectively. First, you write the first coefficients of the first equation and second equation and third equation. Then x and b equations also you have to write. Then first find the determinant value of a. We get the determinant value is not equal to 0, then only we find the a inverse. If it is not equal to 0, here it is 4, then we go to the next one. Then x equal to b, x equal to a inverse. First you have to write these equations also. All steps are very important here. It's the 5-mark questions asked in the annual exam paper. It's the 39th question asked on 39 40 question is asked in the examination. Therefore, you must study well these steps in the problem. A inverse is the present of A divided by determinant of A. Then finding the cofactors is very important. You have to find 9 cofactors here. Therefore, you have to find the cofactors. First, you write the 11th one cofactor of 1, 2, 3 like that. Then find first one is plus, next one is minus. Then is plus. You have to write the same elements or cofactors directly. Then you take the transpose. If you write the elements A11, A12, A13 here, you can't transpose again. You get the same adjoint of A. Because adjoint of A is the transpose of the cofactors of the A. The cofactor matrix. Therefore, x is equal to adjoint of A. We have to find the finding the cofactors. You write it as A11, A12, A13. You don't take the cofactors. Then you write this equation and find these values. You have to multiply these two matrices. Also very important. It is 3 by 3 matrix. It's 3 by 1 matrix. You can multiply these two matrices. Then you find the addition and subtraction. You can use here simple calculator also. Don't mistake here. If you make mistake here, you can't get full mark. Therefore, you write properly and take the cofactors values and addition subtraction is very important. Then by simplifying these two, we get x, y, and 2 matrices. By equating corresponding terms, x, y, z, we get the same. Thank you.